Hello everybody. Today's discussions is to be speed control of three-phase induction motor from rotor side control. Here, the topics discussed is wound field rotor, conventional and also static scherbius and static Kramer drive. Here we are having different types of induction motors based upon the construction point of view. That is squirrel cage induction motor and also slip ring induction motor. The slip ring induction motor is also called as a wound rotor induction motor. Here, the squirrel cage induction motors are having medium range of torque values. At the time of the starting, they can produce medium starting torques. If any application required high starting torques at the time of the starting, it can be possibly produced by slip ring induction motors. It is also called wound rotor induction motor. In the same way, the construction point of view, if you consider the squirrel cage is having a rotor with a copper bars or aluminum bars are placed in the rotor without a winding. But in a slip ring induction motor, the rotor is designed with wounded with a three-phase distributed winding as same as that of the stator winding. Here, the three-phase distributed winding is wounded in the slip ring induction motor rotor. The three terminals are connected towards slip rings, and these slip rings are attached to with a resistive circuit. Nothing but rotor resistance control method. That is, if any adding of resistance value to the slip ring induction motor, there is a possibility of improvement in the torque at the time of the start. That's why these two induction motors are divided depend upon the applications. That is, one is the first one, a medium starting torque, and also slip ring induction motor that can be produced high starting torque. It can be possible by adding a resistance value into the rotor circuit. Coming into the point, here, introduction to the rotor resistance control of induction motors. A rotor resistance control is one among the various methods for speed control of induction motor. In this method of speed control, the rotor circuit resistance is varied by connecting a variable external resistance, and this method is only applicable for slip ring or wound rotor induction motor. Here, the speed control of three-phase induction motor drives from rotor side can be possibly controlling is achieved by using of wound rotor induction motors or the slip ring induction motors only, not the squirrel cage induction motors. And these are the two types of the induction motors. Here, if you observe, the above diagram shows that squirrel cage induction motor and the same different parts that are placed, assembled, and the below diagram which shows that the B diagram, slip ring induction motor. The slip rings are placed, the slip rings are, three slip rings are placed here, and these three slip rings are connected with the three terminals towards the external resistance circuit, which is connected from outer side. That is, by adding an external resistance into the slip rings, the slip rings which are attached towards the three-phase distributed winding of the rotor. So, by adding the rotor resistance value into the circuit, external resistance into the rotor circuit, therefore, the torque of highest value can be achieved at the time of the starting. Whenever the rated speeds can be attained, is there any possibility also to disconnect the external rotor resistance also? But a star connected rotor resistance circuit is connected directly towards the slip rings of the slip ring induction. Therefore, this method is not applicable for squirrel cage induction motors. Yes, for squirrel cage induction motors, the construction of the rotor is to be different with respect to the slip ring induction motor. That's why this method is not applicable for squirrel cage induction motor. Here, if you observe the torque speed characteristics of induction motor to rotor resistance, that is, while adding the rotor resistance, how can the torque value can be improved? It can be observed at the time of the starting point, that is, having a less slip value or a low slip value. Here, if you observe, the rotor resistance R1 is greater than R2 greater than R3 value. Here, previously R3 value has been taken. Having with, if you consider A is the pointer for the slip value, that is 0.25, if you observe, from the A point towards the y-axis on the torque value, if you observe, the torque is to be somewhat less value, or it should be some x if you consider. After some time, with respect to R2 resistance, that is R2 is a greater than R3 value. This from A point, if you consider the torque value is to be somewhat improved. That is, if you consider Y point. Next onwards, from the origin towards the resistance R1 value has been added. That is, resistance value is greater than R2 and it is greater than R3 value while adding the external resistance circuit. Therefore, with respect to resistance added, the torque value is to be this much. Nothing but by adding an external resistance into the rotor circuit, the torque value can be improved. At the time of the starting, we can get highest starting torques that can be possible by using of a slip ring induction motor with an external rotor resistance circuit. From the above diagram, the maximum torque is to be same for the rotor resistances R1, R2 and R3, but the slip increases from point A to B and C. Here, the discussion is the slip value has been increasing with respect to the resistive circuits, resistive elements from point A to B and also C with respect to these slip values. Having the torque value same, but what should be happening is the slip value increases. That is, increasing the rotor resistance results in increasing the slip value. Therefore, with respect to increasing the slip condition, therefore a reduction is possibility of reduction in induction motor speed. Thus, the rotor resistance control, we can achieve a variable speed at a constant time. Variable speed at a constant time. That's why these type of motors or drives are nothing but constant torque drives. The variable speed but having a constant torque drive. Therefore, this is the most advantageous method we require to getting of a high starting torque. Therefore, rotor resistance control having two advantages at the same time having some of the disadvantages also. That is, this method cannot be employed for speed control of squirrel cage induction motors. This is because of non-availability of rotor winding terminals for external resistance connection. That is, if you consider what we discussed in the starting slides with respect to the squirrel cage induction motors, there is no terminals connected outwards from the squirrel cage rotor. Therefore, there is no possibility to use these type of methods for squirrel cage induction motors. And this method is not very efficient. Why? Because if you added a resistance towards the rotor circuit, we are getting the copper losses. Added copper losses towards the rotor circuit. Therefore, losses in external resistance and losses in carbon brushes at high slip operation causes wastage of energy. Here, by adding of resistance and also we are including the brushes which are attached towards the slip rings, these type of arrangements which causes a high amount of copper losses. Therefore, the system efficiency can be decreases. That is the disadvantages. If you go for a static rotor resistance control of induction motor, we are using a GTO chopper that allows the effective rotor circuit resistance to be varied for the speed control of squirrel cage induction, slip ring induction motor. Diode rectifier converts slip frequency input power towards DC at its output terminals. That is, a static rotor resistance control circuit can be operated by using of a gate turn-off thyristors or the choppers. Nothing but a switches, power switches, power semiconductor switches we are using to control the operation of the static rotor resistance control of induction motor. It can be used for slip ring induction motor. Here shows that static rotor resistance control circuit. From this circuit, if you consider this is nothing but the slip ring induction motor. This slip ring induction motor is connected with a three-phase AC supply. Here, the rotor circuit was also connected from the slip rings of three terminals connected. From this three terminals connected to outwards from the slip rings are attached towards the GTO choppers. If you consider, it is a chopper circuit. Here, the availability of the supply which is coming from the rotor circuit or induced in the EMF in the rotor circuit of a slip ring induction motor is producing currents with respect to the three slip rings. Therefore, I1, I2, I3 currents are the currents from the rotor of a three-phase distributed winding are connected towards the 6 diode bridge rectifiers. Here, if you consider this diode bridge rectifier output has been connected towards an inductor to reduce the spikes from the currents, and it is connected towards the resistive circuit. This is nothing but the resistive circuit, and it is nothing but the GTO chopper. Here, the input and output waveforms which shows the with respect to the turn on time period of a resistive circuit, whenever the GTO is turned on, there is no voltage drop across Therefore, it should be 0. Therefore, resistance value which is also placed across the GTO chopper is also 0. Therefore, the turn on time shows the 0 time period. After some time, GTO chopper is turned off and we are getting adding resistance value. That is, suppose if we consider R is equal to 50 ohm. Therefore, an added resistance R is equal to 50 ohms has been added of a turn off time period of the chopper. And the cycle repeats turn on time and also the turn off time. If you consider how the voltage is drop or voltage across the resistive circuit is to be, again same, whenever the chopper is on, it should be 0 voltage across. After some period, it should be turned off. The GTO chopper is turned off. Therefore, a drop is to be occurs while moving the current of diode bridge current, ID current, or DC current towards the resistive circuit. Therefore, the drop is to be across IDR. The same manner, the static rotor resistance control works. And what about the equivalent circuit of the static rotor resistance control with a chopper control, that is a GTO chopper? Here, if you consider R1 and X1 are the resistances from the rotor, stator, and also the reactance values, and the supply voltage V1 has been connected here. After that, and this is nothing but the rotor circuit which is running with a slip value. Therefore, the reactance which is added with a multiplied with the slip times X2 value, and the R2 is the rotor resistance circuit. Therefore, the EMF induced is equals to slip times E2 value, which is directly applied towards the diode bridge rectifier. And after that, an inductor and also the resistive circuit is provided. This is which shows the equivalent circuit of the static rotor resistance control with a chopper. Here, by using of the static rotor resistance control methods, we are getting some disadvantages. That is nothing but if any induction motor drive can be attached with or can be applied with the load values of compressor loads, and also some fan loads, some blower loads. By using these type of loads, the motor loads can be varied, depend upon the application point. The motor loads can be varied. Therefore, an excess energy is generated due to virtue of its momentum, and it start to run beyond synchronous speed, and it can be below synchronous speed or above synchronous speed. Here, in the rotor, an excess energy will be lost, which is also called it is a slip power. The amount of energy which is wasted in the rotor circuit with respect to the slip is nothing but a slip power. This power can be utilized back to grid, and this scheme is called as a slip power recovery scheme. That is, by adding a external resistance, we are getting the high starting torques with induction motor drives, slip ring induction motor drives. But the problem is to be, while adding a static rotor resistance control methods, we are wasting the amount of rotor energy or excess energy which we are getting from the rotor circuit is a slip power. Therefore, when we reutilized this power, therefore the system becomes more efficient. During the speed control of induction motor, using rotor resistance control, rotor power is wasted in the external rotor circuit resistance. Therefore, there are two schemes for recovering the rotor wasting of rotor power. That is nothing but the scherbius drive and also Kramer drive. If you observe